All right. Happy Tuesday. Thank you for coming. Hope your break was restful. So just a reminder, be working on your project. There's a progress report due this Friday, but just keep working on it. Meet regularly. Let me know if you have any questions. Especially as some of you had a little bit more nebulous ideas, um, you start meeting with your group to kind of define those and make them into concrete plans. So just make sure you're doing that. Um, the graph algorithm packet will be due when we're done with it. Might be today. I think if we finish it today, I'll let you turn it in next class in case you want to take it home, write anything else on it. I am gonna go through this one and be a little bit more strict. So make sure that you've got the ideas there. After that, dynamic programming is our next stop. I do have a reading that I want to send you. I've currently got this. I don't like how I want to go rescan it. But after I have another class after this, and then I'm going to the Giants game. So I don't have time tonight. So I'll do that tomorrow morning and send it out to you, a better scanned version. So make sure I'll send that out tomorrow. So go ahead and read that to get an idea of what like how dynamic programming works. And then we'll do the same thing where we'll talk about it a little in class and work on problems. My plan for dynamic programming is we're going to have a video for this one too, except it's going to be a little bit different, where I'm going to assign your group a problem, and you are going to come up with a solution and present that solution in the video. So instead of explaining like an algorithm, you're going to explain an algorithm for a particular problem. So I'll do some work and refine that and give you the assignment document. Question?
Sorry if I didn't catch it, but that presentation is also going to be a video?
Yes. Yeah. Yeah. So
Whatever we haven't done so far, and that will be what we do.
that's the plan. Yeah. I will go through and I'll try and assign you to I try and like mix up the groups a bit. So I'll try and assign you to a group that doesn't have people that you worked with before. But since yeah, the math might be a little bit weird, so no guarantees. Yeah, so there'll be a video assignment. I'll hopefully have that for you by Thursday. Other questions? Okay. So part of your homework was to go over topological sorting and familiarize yourself with how that works. I wanted to bring up one such algorithm. There's these slides from a Stanford class. So let's say that our input is some, let me make it bigger actually, some directed acyclic graph. And what we want, so this is for the children problem and the prerequisite problem, is that we want some ordering of nodes such that for every edge, U going to V, U shows up before V. And so for our playground children question, maybe we just want to reverse all the edges. And so that way we have a graph where all the bullies are, if we have the, see, can I draw on this? So if we have edges like this, then maybe we just reverse all the edges so that the topological sorting comes out like this. And so there's multiple possibilities. So for this graph, which we have right here, we could start with 6, or we could start with 1. So there's different possibilities, different valid orderings that we can get from this. So one of the things which I think we kind of came up with last time, which was we could say that any node without an incoming edge can be the first element. So just if we find one of those, make that the first element. And then after we decide the first node, remove its outgoing edges, and then repeat. So find something without an incoming edge and place it and continue. But the issue with that is that the time complexity is slow. And so we kind of need a better way to organize that. So the way that this author proposes that, which we kind of discussed in class, where someone said have like a priority queue. We can have, if we calculate, here's the degrees, so here's the incoming edges, then we can put all those ones that have degree 0 into a queue. And then basically kind of do the same idea as before, where we take one of those 0 degree vertices and then decrement the edge. So say you don't have an edge for me anymore. And then if the degree is 0, then push it onto the queue. And there we go, and repeat. So we're always taking out something of degree 0 and putting it next in the ordering. And that ends up giving us a complexity of n plus m, which is better. Okay. So that's my tangent on topological sort. Anybody else have any insights from your homework that you would like to share? If not, that's okay. I just wanted to briefly revisit this. All right, so we're going to work on this one last problem in the graph packet. I think I want to, since we're starting at 1:45, I want to push it to, I think, 2:15. And then the remaining, so we'll work on the problem for half an hour, check in about 2 o'clock. And then the other 45 minutes of class, 45, however many, I want to do LeetCode, which is the last page on the packet. So the way that's going to work when we get there, we're going to count off into groups, and then you'll work in your groups, read the problem, put it on the whiteboard, and then have some designated people to code the solution that you come up with. And then we'll take the last 10 minutes or so to go around, and you can explain the problem and the solution to the rest of the class. All right, so let's talk about this is the alien language problem. If you Google it, some form of it will show up as the alien language problem. That's what it's called. And this problem says you are given a list of n words, each of length k, so all the same length, in a language you don't know. You are told that the words you're given are sorted in lexicographic, so alphabetical order, and you want to reconstruct the order of the alphabet based on the words that you're given. So keep in mind that if I am given, so let's say we're doing this with English, and I'm given words that don't include the letter X, then the letter X wouldn't be in my alphabet. So keep in mind, it's determined by the words that you're given and the letters that are in there. Our goal is to reconstruct the order of the letters in that language. So for example, if we get the strings, let's say the language uses Latin letters, The strings we get are QQZ, QZZ, XQZ, XQX, and XXX. The order, because we know that they're sorted in lexicographic order, we know that this means that Q comes before Z comes before X, because we're given the words in this order. So we're given some list of words, and I want an algorithm to reconstruct the character order. So since this is in the graph unit, maybe use a graph for each node for each letter. And then convince me of its running time as a function of these three variables. So n being the number of words. So for this, n is 1, 2, 3, 4, 5. K being the number of letters. So for this example, K is 3. And then alpha for the number of letters in the alphabet. In this case, alpha is also 3, because those are the only 3 letters that appear in the words. Okay. Go ahead, talk with your neighbors. Do we have any questions, clarifying questions before we start? Yeah.
So is only the first letter of the word, like an example, you have Q or Z or X, but Z isn't in the first letter.
Right. Q doesn't appear as the first letter, but Q doesn't appear as the first letter. But, or yeah, Z doesn't appear as the first letter, but Q before Z before X. I think, yeah, well, that is confusing. Other clarifying questions, points of confusion? Okay, go for it. Think about it. All right, let's crowdsource this. So the groups that have a solution, I would like you to maybe take a whiteboard marker and explain it so far.
This first letter is.
I know there's two groups who have solutions.
Because even though this were made up of the last one, these were the first letter is the first letter is different, and it doesn't really matter because that's what social. I don't actually think that would help us, but maybe there's just a problem with that. once you find that difference, the rest, it could be any check, and then change the order.
Okay, so on the board over here, we've got different level trees. The
It's just the problem with our implementation of the overall structure. When you do something, it should be good. The way it's implemented, iterating the rest of the way it's. Tell you.
Okay, so would you like to explain what's going on with this tree back here?
So, putting up the tree, so, yeah. And what we have to do on. More than. So, from the last side, and then the second letter is E, or the second one is E, on that there, and you go down, one, another, and then you put in all your, and then you say, that is, you find out what to do,
Wait, explain the last part again.
you're just taking your directed arrows, so like Q and X. You're taking that.
Okay.
You're looking like a second graph. And then you go Q and D, so you put that, and then you find, so you use one letter that you know. The first letter can have a pointed letter. And then.
Mhm.
Along that. Would be, not to be triple.
Okay, so each of these, so you make trees, individual trees, based on the words that you get. Where the level of tree is the number of letters. So the top level is first letter. Second is second letter. And so on. That's correct? Okay, so then I understand how you get like the Q tree. Then that explains how you get the X trees as well, because they start with the letter X. X, Q, Z gives you X at level 1, Q at level 2, Z at level 3. And so then how do you get the directed edges?
So. First of all, example,
Okay, so this connects in my brain to something that this group over here was talking about, where what they were doing is they're looking at words pairwise and then going through the letters pairwise. So they'll look at, can I edit? Maybe not. Okay. Okay, so thank you. I'm gonna press pause for a second and would like you to talk about this because I think it relates to this idea. Can you explain how your thinking was working? Sure, if you'd like. Yeah, right there.
And once we find, um, a difference in the two letters, we create an edge. So for these, we have Q. Q and Q.
You can take a new one if you want.
Oh, sorry.
You can take a new one if you want.
I'll ride with this one for now. But yeah, Q and Q are the same, so we don't create an edge. And then we come to Q and Z, these are different. And we know that this word comes before this word. And so this difference must be the reason behind that. So we can comfortably create that edge Q to Z. And the way we had it originally, could be wrong, we'll just move to the next pairs of letters. I mean, pairs of words, so QZZ and XQZ, and we process. So here, we start with Q and X, and those are different, so we figured this word is here because X is lower in the order than Q, so we can comfortably create that edge as well. And then these letters, I guess when I say we know it's these letters that are creating the edge, like this could be the first word or the first letter. I'll grab that marker.
Let's throw that one away.
Like these could be Q's, these could be X's, or vice versa, these could be X's and these could be Q's. And it wouldn't affect the order because these are different. And so any other information past that is kind of useless to us. So that's the edge we get from it. And then we just list wordlessly. So that's based on these edges. This topological sort.
Okay, thank you. Um, Yeah, the thing I'm not sure that I agree with, I don't know that I agree that you move on to the next word pair once a mismatch is found. I think that could risk, um, like if Z was just in XQZ and not in the others, then I think we would risk losing Z altogether. Um, so I think, so for me, what I would say is maybe continue iterating through the letter pairs. Um, so you iterate through the words pairwise. So um, I and I plus one. And then you go through the letter pairs. So A0, B0, A1, B1, A2, B2, up to K. I agree that if they're the same, you ignore. And if they're not equal, then draw an edge. Um, but I think you should continue. So for each letter pair, um, so what I think is if they're not equal, but you already have edge containing those two letters, I think ignore. So in my opinion, that would take care of QZZ and XQZ, the words, if we're starting at 0, words 1 and 2. Because in the middle letter, you get Z before Q, which is not, we know is not correct. And we already have an edge going Q to Z. So I think in that case, we would just ignore it and move on and look at the next pair of letters. Does that sound reasonable?
It's for myself, and I think there might be something I'm not getting, but if there's a difference in letters, at least to me, um, I think any information we get after that change could potentially be incorrect, which is why we get that error, C comes before Q, where it's that first change that's denoting the order,
Mm-hmm.
and then any subsequent differences in letters, I don't think it tells us anything about the order. And so I don't think we could um, find an alphabetical relationship based on any pairs that come after that first difference.
Yeah.
I was thinking, what if we were to compare each word and consider the same like each of the letters, and then move on once you see the first difference? It's like
Yeah, so that's
like once you find the first difference, you just want to compare the next one, like the next word pair. Instead of looking at one word, we can break it out. We look at two words and compare. Like you would have like X or Q, Q, Z, then Q, Z, Z.
mm-hmm.
You could put one on top of the other and just compare like Q and Q are the same. Q and Z, that's the first difference we see. So let's make an edge towards it. And then let's move on. And then we do Q, Z, Z, X, Q, Z. Then you see Q, X.
Yeah, so that's what we're talking about. So the question to me is, if we're doing this where we look at the letters pairwise, could it give us meaningful information to continue looking at pairwise letters once a mismatch is found? I have a conjecture that it's not meaningful. Do we agree with the conjecture? I see you nodding your head. Why? Mhm. Yeah. Because to my mind, I think I'm envisioning a situation. Let me copy this and then see if I can come up with an example that doesn't break it. Um, so if I add these two words, so if we have XQX, XZX, right, because Q comes before Z comes before X. So if we have XZX and XZY, is this covered by the algorithm?
It's not covered by the algorithm, but I think it would go against the premise of the problem. Because this would no longer be a sorted.
Wait, so why is it not sorted?
I think XZY would come before XZX.
Well, okay, so we're given, so the example here is we're given only 3 letters in our alphabet. But I'm trying to introduce a new letter
Oh,
and try and figure out and see if, because Y, Z doesn't appear as the first letter of any word. Y does also not appear as the first letter of any word. Would we discover Y and add it in the correct location in the alphabet in this case?
Y comes after X.
That's what this tells us.
Sorry, just for clarification, why? Why is
So-
after X?
So currently we have Q before Z before X. And so I think this would tell us that Y comes before after X. Do we agree? Yeah. So the question is, like, does this algorithm as stated give us this result? Think it would, because we're looking, so because for this case, we're looking for mismatch. And so XZ would be discarded. So ZZ, okay. X, Y. Oh, we don't have that, so X should come before Y. So maybe we do need to discard. Okay. Okay, so thank you for presenting that. Let's go back to yours and see if that discussion gives us any insight. So here you construct a tree for each tree formed from the words. So the top level is first level. Then the second level is the second letter, and so on. And so then so I think you read like the level order. To get the directed edges. So Mhm. And so this would give us QZ and QX. ZZ and ZX. So how do we, so I believe that this gives us Q before X. How does it give us the order between Z and X? Can you clarify that? Okay. And so then I think okay. Each tree is formed from the words, where the top level is the first letter, second, so there's K levels in our tree. The directed edges comes from where's the, okay, let's put that in parentheses. So we read the level order for the trees to get the directed edges. When there's a change in the letters across the level, we get order information. And then I think we would need to do a topological sort again to get the order. Because we create the graph from the directed edges. And then we do topological sort to get the order. Any points of confusion? Okay, so these are two solutions. Anyone else have an approach or maybe part of an approach? Go for it.
But why would the graphs and some doubts like Jason, but I didn't do the directed edges. Except for among the, like move nodes and source nodes of those three subgraphs. And then I just did a level order traversal for each subgraph, like for each letter,
So like,
each first letter, for like Q and then X.
right, isn't that what we were just talking about?
Yeah, but instead of doing a topological sort of making another graph on those edges, I just use a level order because it outputs like a different set for each level.
Mm-hmm.
And then I did union all the same levels of all the different letters together, all the moving. And then you can from the bottom, like, all the layers union together go from the bottom layer and union that with the second layer or the previous layer. It's once again. You really have to go first. And I'm gonna get to sort it.
Okay, so instead of topological sorts, you you do when you were at the level order, we union, so QX, fine. QZ, QX. What does that give you?
Right, QZ, and then since you're moving it, you get to QZX. Then the bottom layer would be. That one. Then you union above, so it goes EX into QZX.
Wait, hold on. I'm confused about the second level. So we have Q pointing to Z and Q pointing. Oh, okay. So,
So when you're making the graph, you populate the left to right based on the order of the words given to you.
so,
Order.
okay, so you start with Q and Q, those are the same. So then,
When you do the level for each subgraph. For
Mhm.
would be QZ for layer 2, and for X
Yeah.
would be Q. And then you union them together, removing the duplicates, and you get QZ and then X.
I'm concerned about this order. Is this what the first two levels of that tree look like? Wouldn't it be, is it the X, Q, and then XX?
Yeah, it's just like that.
Okay.
That's the order was given. Words were given.
Okay, so the clarification that I need for your version is, what does union mean? So like, yeah, because here's the thing about algorithms. Like, we know what it means to union two sets, right? We know what the result should be. The question is sometimes, how do we find that out? Like, how do we calculate the union? Because mathematically, like, we can just do it and it's fine. But when we're working with data, it may be a little bit tricky, and the choices we make in implementation can be different in runtime. Like with the topological sort, the two examples we saw just today, where depending on which topological sort we choose, it costs a different amount. So this is an additional step that is, so like if this was on the test, I would maybe circle this and say, I don't know what this is about. But like probably let it go. Yeah.
That's like the Python set union. If that's built into remove duplicates.
Okay. Yeah.
That might.
Okay. So that's where, yeah, that's where it comes from. Um, okay. Okay. Any other thoughts? Or what other thoughts do we have about this? So I know one of the reasons that I like to give you some time to think about it before we all come together is because you may have approached this a different way. And so I want to give you time to kind of like flesh out those ideas before like coming out of left field with a completely different way to think about it. So yeah, were there any other kind of approaches that you were starting to think about? I know you maybe had something a little bit different. Do you want to talk about it?
So,
Sure. Not that one.
I'll take mine. But, so since we have a resort then, I was just looking at the first character of each word, so but we had a few. I went through like a folder, but look at the first position of each character. And depending on the character that we meet, so. And depending, we still have the first position, and depending if they're unique, we have them point at the next unique character. Since Q's unique since the first one, we have a point at the second one's the next unique position, and ignore this Q that's not unique. Then we move on, once we go through the entire list, we move on to the next index. So it's like index 1 or 0, the next index. We start Q again, because it's also still unique. Move on to Z, because the next index over there. And from there, we're gonna go to X. And then with that, then for like the third and third, Z. And there's no real other complete indexes. Okay. So we go from Z to X, and then that's how you do it. And you talk a lot of sort to like figure out the details. I didn't really do this.
Okay, thank you. Any thoughts? Do we think this algorithm is robust enough to handle it?
I'm pretty sure.
Well, so my first concern is not necessarily the time complexity. My first concern is, does it give us the answer? Is it correct? And so what I think it's doing, it's kind of like what we were doing over here. Where we're maybe not necessarily going through words. We are kind of going through the words pairwise, where if we start at the first word and then we go through until we find a word that starts with a different first letter. And so we are kind of searching for pairs that way as we go. So as as written, I think I'm missing the step. So you get Q to X. And then for the second level, you get Q. That's not a Q. Q to Z to X. Based on this description, what am I missing so that because I currently have it set up to add one edge. How do we add the other edge?
You just, the way I had in my head was that you keep progressing through the for loop until the for loop doesn't stop when you find an edge, for loop stops when you reach the end of the list, and it only skips characters that are not unique.
Okay, so
I'm pretty sure that's how.
so we say that Q is the first letter. And then we go through, we find X, that's J. And then, okay, Okay, so first we've got Q and then we've got Z. And then Q again, and then we get to X. And so I think that gives us Q to Z and Q to X. So maybe we need a little bit. I mean, I think we have that here too. And so I think having this is more precise than Q goes to Z, Q goes to X, because I don't necessarily know that Z goes to X until I do the topological sort. Okay, we're pretty much at the end. Thank you for participating. I know this is a hard problem. And so thank you for engaging. Thank you for trying to come up with a solution. Since we ended up spending the whole class time on this, sorry about that, but also not sorry because it's good practice, especially good practice in if you come up with an initial solution, we need to be able to refine it and say, what exactly do you mean? How do you know that it's correct? Okay, so next time we will definitely do LeetCode, and that'll give us more time to work on it. I will still try to get the dynamic programming stuff out to you tomorrow morning. Yeah, question?
The package tonight then? or-
No. I will move it to I'll move it to Thursday. So, your homework is to go through the packet and make sure that you've written explanations, not just pictures. So this document, the document that I've drawn on, that's on Canvas. So feel free to go and reference that. I would like written explanations for the problems like it was a test question. So go through, write that all out, and then maybe give it to me on Thursday. All right, thank you. See you next time.
Yeah.